So, all right. There was very little in pull requests this week. I didn't see any new or closed PRs, which is not terribly surprising given that everyone's very, very focused on Quincy. There was one that was updated that I saw. This is this set tracing compiled in by default PR that folks on the RBD side have been looking at. I don't think we have Deepika this week, but she reviewed that and it's gotten a couple of different updates this week. So it looks like it's still under active development. We'll see what the outcome of that is. Coincidentally, one of the PRs that appears to maybe have caused a performance regression a while back that we didn't notice was also related to tracing. So keeping a good eye on how much of a performance regression this PR causes, even when disabled, is probably going to be important. Beyond that, I did not see anything else really going on the performance front this week for new PRs. Oh, go ahead. Absolutely.
Yes, and I have something which I wait. You don't see it yet because I wait because of Quincy, the work on Quincy. I'm not sure it's exactly the performance what you do. There is a PR, but I'm going to do about the balancer. There are very rare cases in which the balancer, the existing ones, the calc PG app maps, is really stuck with. It's not infinite loop, but it works. I have an example where it works for more than 10 minutes. Actually, one function call. It really it goes into some huge calculation. I have a very simple fix that changes this, it reduces to less than 20 seconds with a bit, very, very small changes and rare changes in the results. It changes a bit the results of the balancer. Probably when the Quincy feature freeze is going to it's going to be more quiet, I'm going to push this PR. It's like maybe 12 lines of code in the calc PG app maps, but it's at least for the examples that I have about this huge performance issue. I don't think it's an infinite loop. I think if I give it enough time, it will finish. But I'm going to. It solves all the use cases all the examples that I have for this. So.
Just to make sure I understand, this is only an issue when the PG autoscaler is enabled?
It's not the PG autoscaler, it's the balancer. It's the capacity balancer.
Okay.
So there is one, I have like dozens or something like this, different configuration files from different systems and with pools which are worth balancing because they are large enough. I have something like, I don't have the statistic here, but something like 30 large pools that are worth balancing because all kinds of small pools it's not really interesting. And out of them, I have one pool with one configuration which causes, I run it in a matrix of multiple parameters, but I see 6 examples all on the same pool where the compute doesn't stop. So I give it a timeout, and the largest that I gave is 600 seconds, 10 minutes, and it still doesn't complete. And after my fix, it completes in less than 20 seconds.
Oh, excellent. Did you say is there a PR yet for that, or is it still just in a branch?
It's still a branch. I'm just waiting because now there is a lot of noise around Quincy. I want there to when they close this, I'll put it as a PR. Again, it's very small from code perspective. It's only it's about a dozen lines, maybe only 10. So it's
You can submit a PR and just put, tag it with "Do not merge" or something if you're not ready for it to merge yet, just to get more eyes on it.
Okay, okay, I'll do it.
Um, cool, cool. Excellent. So, were there any other PRs this week that were new or closed or updated that I missed, guys?
So, Mark, I don't know if you saw the tracker issue I posted there, but I just came across this today. It's affecting Quincy and seems like performance kind of drops to a halt after a couple hours.
Did you put it in the pad or the chat window or?
I put it in the pad
Quincy,
under new pull requests.
Oh, okay. Sorry, that was the one I was looking at. I thought that was what Josh Solomon was talking about.
Quincy, is it the same one which
What's that?
Tim filed? Hey,
Yep, it's new from a couple hours ago, yeah.
yeah. So yeah, we have been testing in internal team workload DFG, Quincy, and from remember Mark, I talked with you, Mark.
Yeah.
It's the same tracker that the. So let me provide some background to this one. What we did take the Quincy and we started we deployed it in a 192 OSD cluster. It's a hybrid OSDs, DB in Flash like NVMe, and the data disks are in SDD. And we have fill workload first. We fill the cluster, and it's a small object. Like the objects start from 1 KB to 256 KBs. Maybe the histogram is already provided in the tracker, and it's a cost bench workload, S3 completely RGW workload, and we have 30 drivers, cost bench driver. It means that around 160 number of workers we are running around 2100, but we slowly reduce it. We were thinking that client is maybe putting a lot of load, so we reduced it to 1680. We disabled the auto scaler, we pre-sharded the bucket, nothing helped. So what is happening is that reducing the count of the workers, the cost bench workers, helped us to pass 1 hour hybrid workload, but not the 48-hour aging. So fill is going fine, but not. I mean, it is not adding all like 50 million objects in each bucket. We write around 50 million objects in each bucket. Some few objects are missing from each bucket, but it's still okay because it's just a fill. It's not a write, it's a fill. In the cost bench term, client doesn't wait for a write to be successful. It just keeps writing the data to the bucket. And after that, we do a hybrid, which is a 1 hour hybrid, and then followed by a 48-hour hybrid. Whatever we have been tuning, 48-hour hybrid was not successful at any point.
And so after 3 to 4 hours, nothing you've done stops this from just ending or just stalling.
Yes.
Yeah.
And the cluster health has been always fine. Like no saturation or any WAN or MON dying on OSD flapping, nothing.
Have you tried, after it gets to the point where it stalls, have you tried sending any new I/O to the cluster via other mechanisms?
No. Like S3CMD or like put bucket or create bucket, something like that, right?
Yeah, or even just like a Rados bench to a separate pool or something, just something to see that the OSDs are still responding and doing things.
No, nothing we tried out. It's just sitting idle. The cluster is idle right now.
Yeah.
So,
Casey, do you have any sense of whether or not you think anything in RGW would be not responding, or do you think this might be lower down in the OSD?
I really haven't had a chance to look into this.
Okay.
if you want, I have cluster access. I can run commands if whatever you want right now also. So, I mean, I don't know if it is the right forum, but yeah, the cluster is there. It's in the same situation what reported in the morning.
Okay, yeah, I assigned Mark Kogan to this, so you might reach out to him and offer assistance. But he's also been tracking some memory growth in RGW, so it'd be interesting to see if we see the same thing in this workload.
So what I will do, Casey, I'll email Mark Hogan with cluster access detail. Okay.
Yeah, and if you guys determine that you think RGW is waiting in the OSDs, that they're not responding or doing the work, let me know, and we can try to get somebody looking at that too.
Cool. Thanks, Vic. Yeah. And Mark, I just wanted to make sure you were aware of this one.
Thanks. Yeah, that's good to know. Lots of changes in RGW, but also some changes in the OSD. So I have not seen anything like this on the tests that I've run, but I have not been running like 3 to 4 hour kind of long running RGW stress tests. So I have not seen this. All right. Well, yeah. Thank you guys. Thanks for looking at this. Anything else that
Mark,
I've missed?
one point regarding the discussion that we had last week about the RocksDB, and this we talked to the people from SpeedDB. They also saw the recordings. They're willing to and they are committed to opening the source. We talked about this. They are willing to be here next week. So put it in the agenda, and let's see what how they can discuss with the people from DigitalOcean and whether.
I'm not sure if next week is going to work. Intel is going to be giving a presentation on OpenCAS and their work looking in comparison to DM Cache either next week or the following week. I don't know for sure. I gave them the option of either, and they're going to try to figure it out. So we might be able to do it next week, but that's still maybe.
So keep me in the picture, and I'll also update the people from SpeedDB, and let's do for the next week and the week after. We'll do both. Let's see. Intel decides where they are, and on the other Thursday we'll bring the people from SpeedDB. I'll talk with them and make sure that they know that we may change it because we have prior.
Yeah, I do want to point out too that we're happy to talk to them, happy to bring them in to present on anything that they'd like to talk to us about. But until it's open source, and especially given that BlueStore is kind of very quickly heading towards more of a stable implementation while we develop Crimson, major changes like replacing RocksDB are definitely something that's going to be more difficult to do as time goes on, right? So just they should know that before we commit to a bunch of their time.
I will do it. On the other hand, let's see if they can prove that they can solve the problem with DigitalOcean. It's maybe worth doing the work. That we have a use case. If they could show that they can solve this problem, maybe it's worth discussion. My experience showed that while they did huge improvement to RocksDB, it didn't help in Ceph. So I'm not that optimistic that it can solve the problem. But if it solves the problem, it's interesting. If we see that it doesn't solve the problem, then okay, it doesn't solve the problem.
So Adam, you weren't here last week, but the folks from DigitalOcean raised some issues that they were seeing regarding RocksDB. And I think Josh was thinking that maybe the SpeedDB folks had some insights or thoughts regarding that. Josh, do you want to talk a little bit about what you were thinking? I know Adam has already looked at SpeedDB a little bit, so maybe it'd be a good discussion to foster.
I must say that I did. Go on.
Sorry. I just wanted to say that I will be happy to try SpeedDB again, especially that we made some improvement changes to BlueFS recently. Maybe that will also impact the performance that we were not able to gain last time. So maybe there is some change, some value to make a test.
And I can tell from my perspective, I just did pattern matching between what the people from DigitalOcean said and what we heard from SpeedDB in the past. I didn't fully understand their problem, but it was clear to me that they had problem with Tombstone and with the delete process within RocksDB, and I know that the SpeeDB claims that they improved it significantly. They need to prove it, so that's why this whole thing started. I'm not sure. I'm not sure that the problem is mainly in SpeeDB, or I didn't even have a feeling how confident the people from DigitalOcean were that the problem is only in SpeeDB, not in other places.
So
Only
Adam,
RocksDB, sorry, only RocksDB, not in other places. So, but if it is there, maybe we have a solution. If it's not there,
it sounds like we plan to invite them. Why don't we get the DigitalOcean folks also in a future meeting on the same forum? And I'd also like to hear their plans about open sourcing SpeeDB. I think that's that'll give us a good idea.
We've already talked to them several times.
Yeah.
Do we need to do this again? I think we've been through this like 5 times already.
Yeah, they committed. They already told us that they committed to a customer. I don't know which one, that they are going to open source it within 3 months. So they're in the process of open sourcing it without us.
Great. Let's talk in 3 months.
We had the problem now. I think it's good to see the
Josh, I'm saying we're spending
too
too much time talking about this, which doesn't exist yet. Let's wait for 3 months and go to the next topic.
I think that if we have a solution for DigitalOcean, I think it's not the thing. They came with a specific problem they claim with RocksDB. If you don't have a solution for them, you leave them with the option, while SpeeDB are working on opening the source. So you wait until it's published in order to start tackling a problem that exists now for important user.
well, Josh, we can't tell DigitalOcean to use the RocksDB replacement, right? And until we've actually done any testing, that's like throwing them unverified software and saying
that's the biggest problem, right?
Yeah.
Let us assume the SpeeDB solves the problem. How do they even consume SpeeDB at this moment unless it's open source, right? That's where the problem lies. If they have open source and they come to this meeting and they talk about how they have done it, they present a solution that somebody else can try, that will be a useful thing to do. But if there is something that is far-fetched and we make promises and I want to get to resolution. And again, like what Mark said, we don't want to invest too much in BlueStore given that C-Store is the future. So I think it'll be better to talk when it is open source, and then we can have somebody try their solution.
On the other hand, if we had DigitalOcean that will clearly state what the problem is, maybe we could use RocksDB to solve that.
Adam, the gist of it is that when they went and were regularly compacting in the background on a schedule, and it gets deeper into this, but the very high level, when they were regularly compacting, it dramatically improved performance for them in some situations, rather than just letting compaction happen on write, essentially.
I see Josh here from DigitalOcean.
Oh, yeah. Josh, you're here. Sorry, I didn't see you in the
No, that's fine. No, been enjoying the conversation. The issue essentially is that Tombstone and overwrite buildup causes such a degradation to list performance that we start to have significant index performance issues, leading to even OSDs going down from time to time.
Adam, do you remember? Oh, go ahead.
Yeah, sorry. No, you go ahead.
I was just going to ask Adam, do you remember when you were testing SpeeDB, did you look at like iterator performance or anything else where tombstones were having, kind of a big effect on RocksDB in previous things that we've seen?
No, not at all.
Okay.
The compactions were just a side effect of having a lot of traffic and needing to compact incoming tables. That was just it.
I don't I don't remember when we talked to the SpeedyBee folks before, and I wasn't super involved beyond at the very beginning, but I don't remember them saying that they had a solution for that problem. I think I even brought it up specifically that we wanted to be able to reduce the impact of tombstones on iteration performance. I didn't think that they said that they did that better, but I could be wrong. That was just my vague, probably poor recollection of that conversation.
Yeah, Mark, I think we've have other things on the agenda. Can we just move to those? I've called
Yeah.
some people for the Gibat stuff, so we can circle back on this topic.
Yep. And okay, so let's move on. I will just very briefly talk about Quincy performance testing so we can move on to Giba. There's in the Etherpad, there's a spreadsheet I linked there. Folks can take a look at it if they want to, but the high level of it is that compared to previous releases, read performance is very in line. Sometimes it's a little faster, sometimes it's a little slower, but nothing that I'm too concerned about. On the right side, however, on these AMD nodes that we just got this year, so we haven't been testing these very long, there's kind of a clear difference between going back to Nautilus all the way to Quincy. In some cases, we're seeing really almost progressive degradation of performance in these tests. In other cases, like at the very bottom, if you look at column Q, row 93, you'll see that there's a chart for 4KB random writes, and there's this kind of situation where Nautilus was really good, then Octopus through Pacific we weren't doing as well, and then Quincy we kind of clawed it back. So I went back and have been doing bisects all week trying to figure out what happened there. The reason that Quincy is looking good compared to Pacific is due to Gabby's excellent PR for changing the allocator behavior and getting a bunch of stuff out of RocksDB. That's what's giving us that win. And we're actually faster than Nautilus, which is good, but we could be faster yet, I think. If we go back and look at Nautilus, what happened is initially in Nautilus, we did not see that good of performance. It was much more in line with the other results. The win that we got in Nautilus happened in 14.2.8, I believe, when we introduced the 4K min alloc size by default for SSDs. On this platform, that was a big win. It gave us a really significant performance jump, more so than I remember seeing on the Intel machine at the time. So that really helped. But it turns out that change was backported to Nautilus. When we implemented it in the pre-Octopus time frame, it turns out that right around the same time we made that change, we also introduced a number of PRs that actually were hurting write performance. It's a little hard to tease all of them out, but the one right now that's standing out is this PR where we introduced changes to trace points. This is this 29674, which I will link in the app window here. Specifically inside that PR, there's like 10 commits, and it appears to be one of the 2 commits I've got listed in the Etherpad that are doing that. That was kind of the biggest, most straightforward regression that I saw. I think there are others, but unfortunately, we're talking maybe 1% or 2% at a time. So the 4K min alloc size change was a big win, but then we also had a bunch of smaller PRs that were regressions. This is exactly the kind of situation that's very hard to tease out, especially when they happen kind of close to each other in time. So the good news was that because we didn't backport a lot of those other regressions to Nautilus, we only saw the big win, and that's why it really stuck out in these graphs or these charts that I showed. my hope is that we can win back some of that, and we'll even see Quincy doing a little better in these write tests than it's doing now. Either getting it back to Nautilus in some of the larger write tests, or being an even bigger win in the small random write test, where Gabby's PR is providing even better wins. So that's what I've got on those tests. Any comments or questions there? Okay, if not, then Neha,
just one quick question before we move on. So have you tested any RGW workloads yet?
I have. I didn't provide them here because I haven't graphed out the results. I've been so focused on these RBD results that I wanted to see if I could identify the regressions and see if there are any easy wins there, and then go back and retest RGW. RGW is more complicated because we also saw some regressions in RGW itself. RBD tends to be a little bit more it probably is seeing a little bit less development, that has big performance impacts compared to RGW right now. So in RGW, we know that back in the Pacific timeframe, there were a couple of regressions that were introduced. It's probably going to be harder to tease out if those are OSD or RGW regressions specifically. But we do have some results for it. So I probably won't dig them out for this meeting, but we do have
that's
them.
fine. That's fine. I was just curious because the stuff that we started off this meeting with, for Quincy, that Vikyat was talking about, I was just wondering if you've seen something similar or not. But when you have the results, let's talk about it then. Let's move to the next topic.
Yeah, that sounds good. Okay, so Neha, do you want to start us off on Gila? This is kind of your baby.
Yeah, I mean, my baby. Come on. But I think you are the driver at the moment. I can clearly see, and you've done.
No! I don't want to be the driver.
No. I mean, it's good stuff. So, I mean, in general, I think folks already know Giba is like a scale cluster. It's mostly logical scale. We've got close to 1,000 OSDs running with very less resources, especially with memory. And Mark has been suggesting and even tuning the cluster to behave, or at least hold up, I would say, not behave, hold up in such conditions. So one of the things that we wanted to do was to use this cluster to run some kind of workloads like across the board. And Mark, you've already installed a bunch of stuff that can help us run CBT on this, right?
Yeah, CBT needs to be 001. It's not a problem. The only thing we might need to do is David had suggested that the way he wants people to do SSH keys here would be to use the forwarding capability, and to do that with PDSH, there needs to be an environment variable set. It shouldn't be hard to make CBT work that way. I'm not sure if we can do it easily at the moment, but a quick PR would take care of that. So
awesome.
We just may need to make a slight change to CBT for that to work right. But otherwise, I don't see any problem with running CBT workloads on this. It's fairly straightforward.
Well, awesome. So I think the first step is once, Mark, you can get some kind of workload running on this cluster with CBT. What I would like for us to do is, I think Aishwarya and Sridhar, they're both on this call. They've been actively working on QoS, background QoS for Quincy, and this will be an opportunity for them to test some of the QoS related settings and parameters that we have applied for Quincy, especially around how mclock behaves with scrubbing recovery while IO is running on this cluster at this scale. What they have done so far is tested at smaller scale with SSDs. And now there is a test plan that we've created kind of to replicate. They have been used. I mean, I guess I should just give it over to either Aishwarya or Sridhar, whoever wants to talk about it a little bit. If you can give an overview of what you guys have been doing and what the motivation for this Giba cluster testing is.
Okay, I can go ahead. So what we've been working on is currently the background tasks like recovery and scrubbing and seeing how mclock handles it with client and how the different mclock profiles work. And we've been doing this on the officinalis nodes, but it would be great to do it with 1000 OSDs. Um, and our tests currently run client and recovery together, and there's a new test coming in that runs client recovery and scrub together. So, and we collect some stats on recovery and scrub from PG dump. So we would really like to see it on a larger scale. That's basically what we want to do with the Giba cluster.
So I think there's a test plan that has been linked here, but it's a private document, so we might need to convert that into an Etherpad if there are more folks interested. Yeah, no worries, you can do that offline. But I guess, yeah, Sridhar, you had something?
No, I was just going to say that we have broadly outlined the test steps for each of the tests that we have identified. For example, the recovery test, the scrubbing test, and the combination of the scrub plus recovery test. So these are high-level steps that CBT currently does. So once CBT is up and running, what we have tested so far is at a scale of about 100,000 objects in the recovery pool. So we could, increase the scale to a much higher value, and then test the same test cases and see how the cluster behaves. So, with different mclock profiles.
Do you want to, for folks who are not aware of what these different mclock profiles are, do you want to quickly describe what they are and what they're meant to do?
Yeah, essentially, so in mclock we have defined three profiles. The default profile is called as the high client ops, which gives more reservation or preference to the client operations, while still giving adequate reservations to background recoveries and scrub related operations. And the idea is to get a baseline first on this machine, and then switch the profiles around. For example, one of the other profiles that we have is called high recovery ops profile, and also there's a balance profile. So with high recovery profile, for example, we could run the same test and see if it actually helps in giving higher preference to recovery ops, while still allowing the client ops to have a decent bandwidth without it getting affected too much. So yeah, these are the three basic profiles that we have defined, and the plan is to establish the baseline first and then test the different test cases with these profiles and extract the numbers to see how mclock is faring.
Cool. So Mark and everybody else, I mean, how does this sound, and if there are any thoughts, ideas, incorporations that we can make into this, I'd be curious to know what those are.
So I feel slightly relieved in that I actually don't know a ton about mclock, and all of this sounded wonderful to me. So I was able to just say, "Great, go nuts, do what you think is right."
Awesome. And I can clearly see Ronan is happy about this. I don't know about others.
I think that was the Lego Saturn V.
No, yeah, I'm happy about this, and
I'm sure scrub test makes Ronan more happy than the Lego.
I'm doing a lot of minor tweaks to scrubbing, and I don't really know if I'm really improving performance like I think I'm doing it. This would be a great tool to test this from time to time.
That's good. That's really good. We should. We've got lots of peers. We should get into CBT. They're sitting out there, but we should definitely get the both any kind of scrub testing and mclock changes in if they're still outstanding. It's neat that you guys have figured out ways to do this.
I have a related question about that, just to understand. Currently, there are a lot of weights, etc., within grab code. Some of are disabled when the mclock is the scheduling method that is chosen. But do we envision a time when we can remove the need for any specific manual scheduling, manual delays, and just assume we have the mclock?
Yes, I think the idea is to remove all the manual configurations that we add. For example, the scrub delays and all that. The idea is to disable all of them and let mclock, based on the profile, let it do the allocations and let scrub go as per the setting that we have. So the long term, sure, we want to eliminate all those scrub sleeps, for example, that we have defined, and let mclock do its work without any of these settings. Just based on the profiles, it should work fine. That's the long term goal.
Let me rephrase the question. If I'm currently revising code, and do I need to still keep all the mechanisms that do not use that simply use manual intervention, or can I just not insert them if I'm in new code?
Well, currently the way the code changes have been made, even if we add those settings, the mclock code overrides those back to
to zero. Yeah, I know.
Well, basically, it disables it essentially.
Yeah,
that's what the code does right now.
That I know. What I'm asking is that do we need to keep the code that uses those configurations?
So I guess the question is about when that new code lands in, right? It's a matter of maturity. Like mclock, this is the first release where mclock is going on as default. If things look good and we get much more confidence in like mclock is doing the right thing and we don't need these sleeps are all associated with WPQ, which is the old OSD op queue that we used to use. At some point, we can just say, okay, we don't care about WPQ because mclock is far better. And at that point, we don't need those sleeps anymore. So like it all boils down to that new code. If it is targeted for something, let us say the R release, sure, we probably still need those sleeps implemented and we accounted for just in case somebody needs to switch to WPQ for performance reasons. But if you're talking about further down the line, maybe not. So I guess it's about timelines.
Okay, so that's a good answer. R is still optional for R.
Yeah. I mean, I would still keep both for R.
Yeah.
Okay, good. Thanks.
Mm-hmm. Anybody else have any other thoughts? And I know there are other folks who are doing similar tests on different scale, different kinds of workloads. And I'm sure there's a lot of learning we can get out of each other's experiments that we are doing. So I was hoping that if this could be I don't think CBT has been used at this scale ever, at least in my knowledge. So if we can get CBT to run on 1000 OSD cluster, maybe that can be the workload generator that we can use very easily across any kind of setup that we have where we are doing such tests. And given that it has like scrubbing, recovery, all kinds of tests incorporated in itself, it's a good bundle.
Yeah, Neha, I think the biggest I've ever done was probably about 400 or 500. I've never done 1,000. I've used PDSH on 1,000 nodes before, but not CBT. So that'll be interesting to see how it goes.
A milestone, right?
Yeah, and it'll be easy. It's almost a little bit of an it doesn't actually have to deploy the OSDs, it's spawning clients. So
Yep.
that's basically just invoking PDSH. But yeah, that'll be interesting.
Yeah, to add to it, what Neha, I think in the internal cluster we are going to test the PG deletion performance. So
Yep, that's an interesting point. So, like, we are trying to, spread the load across different groups so that we can get a good idea of how mClock is doing across all kinds of operations, background operations that the OSD does. So, what Sridhar and Aishwarya are going to be focusing on are more like client I/O versus recovery and scrubbing, and Vikyat and team are doing some PG deletion performance evaluation also with mClock.
Generic Quincy and then PG deletion. And Rehan, tell me one thing. What is the default profile? It is high IO or it is balanced?
It's high client.
Okay. Do we have enough documentation in upstream for this feature? I mean, like what these profiles are.
This is one thing I can say yes, because every time we've merged mClock change or mClock PR, there's documentation going with it. While we continue with the meeting, I can paste some of the links in the chat for reference. So maybe Sridhar, you've written a lot of this documentation. Maybe you can.
Thank you, Neha. Thank you, sir.
Yeah, sure, I'll paste it in the chat window.
Yeah, would you like me to move on to talk about row memory configs?
Yeah, I think so. I think in terms of action items, Mark, once you're able to run like one workload or something successfully and everything is set up for Aishwarya and Sridhar to take on, let me know and then we can execute some of the test plan that they have.
Sure. That sounds good. I can try to get that taken care of so that they're not blocked. Shrikar or Aishwarya, do you have a particular workload that you're interested in, FIO or Rados Bench, or what do you want? I can just verify it works.
We usually use FIO.
Okay.
Yeah, that's right. Yeah.
So I've got FIO installed on most of the nodes. There were a couple that were down and one that was stuck on Rel 8, or not Rel 8, on CentOS 8 instead of CentOS Stream, and that was causing problems with the Yum repo. But other than that, I think FIO should be on all of the nodes now. Do you have a specific amount of client workload that you usually try to invoke, or is it just kind of enough to make sure the cluster's sort of busy?
Generally, we have right now the way we have tested is just using one client. So I guess we'll have to just do some experiments to, like you say, keep the cluster busy on one pool with client ops while we are triggering the recovery and the scrub operations, and for example, some other pool.
When you do recovery,
that's how the test works.
Oh, sure. For scrub and recovery, typically in CBT for recovery operations, CPT, at least from what I remember, it's been a while since I've done it, but I think we need to own the OSD to do it. I've never tried that with running tests on an existing cluster. Do you guys let CBT build your clusters, or do you run on something deployed with like Ceph ADM?
As part of the testing, we did introduce a new kind of recovery test. So that's the test that we're going to trigger. It's already there in CBT, actually. There are two types of recovery tests. One that you already had, Mark, and then one that we newly introduced to test with mClock.
And the new test, is that, will that work on an existing cluster with like the use existing flag? Or when you test that, are you testing it on a cluster that's CBT deployed using the Ceph cluster class?
It's the new test is already defined in the Ceph cluster class. So I think it should follow. Yeah, it should work with the use existing flag also, I suppose. But I never tested it though. Each time I have initiated to fresh.
That might be an interesting thing to see. I don't believe my existing recovery tests work when you do use existing because it's not aware of the OSDs when use existing is set. The OSDs are basically just assumed to be there and it doesn't try to touch them. So that is actually an interesting question. Neha, that could be a little bit of a wrinkle here with testing when the cluster is already pre-deployed.
So, what does it do differently? I mean, can you describe for me what does that recovery test do? Like, let us say if we induce recovery by just bringing OSDs down manually, would that work?
Oh yeah, if you brought it down manually, I mean that'd be fine. So like I said, it's been a long time since I've looked at this code and since I've thought about this, but vaguely I remember that things in the Ceph cluster class, like the recovery state machine work, assume that CBT has knowledge of the topography of the cluster, and that happens, or the topology of the cluster, and that happens when it knows and did the deployment itself. Like then it knows about OSDs, it knows where they are, it knows how they were deployed. When use existing is set, that all basically is empty. There's nothing there. It doesn't know anything about how the cluster is deployed. It's just running some benchmarks against it. I don't know that the stuff that I wrote for recovery will work when use existing is set. I don't think it does. Could be wrong on that. And maybe it might be possible to change it so it does. But it's primarily due to the fact that CBT doesn't have any knowledge about how many OSDs there are, how they were deployed, what it should do. It's possible though that you could, if it might work, but if it doesn't work, it's possible you might be able to change it so it just, is basically marking an OSD down and you just force it through, and it marks one back up and you force it through.
Yeah. I think that's what I'm thinking. Maybe that's something Sridhar and Aishwarya, you can verify in your local setup how this works. But even like I'm thinking in the same direction. There's nothing that stops us from just manually injecting failures and let CBT just collect the stats or even see how long the PGs are taking to recover and all that kind of stuff that they have added.
Yeah, it might not even be a hard change, right? I think I just didn't. When use existing was kind of created so that people could run on existing clusters, it was primarily for like running a benchmark on like a partner setup. So like say if Supermicro had some machines in their lab that they wanted to test and like verify that they saw good performance on it, that was kind of the idea, that someone could just deploy Ceph and then run CBT against an existing cluster like that. It's probably the biggest issue is just I don't think it's ever been tested. So that's probably the first thing, to just try it and see if it works or not.
Mm-hmm. Mm-hmm.
Sure, I can. We can try to run it on our local setups and see if it works. And if not, we'll try to see if we can get it working with the flag set. Yeah.
Yeah, and hopefully fairly quickly I should be able to get something running on an example configuration running on Giba so that you guys can do testing there too. I'll probably just set up like 16 client nodes that you can use if you want to for workload. That should be sufficient to really saturate the cluster, I think, given the speeds we're talking about here.
Yeah. Okay.
Cool. Anything else, Neha?
No, I think let's move to the next. We don't have enough time. Let's go to the next topic. But this is good.
Sure.
Thank you.
So related to Giba, one of the things that we is a little tough there when you deploy Ceph through the normal processes is adjusting the tcmalloc thread cache. Maybe it's as easy as changing some systemd type stuff or Ceph ADM configs. I don't know, but I didn't want to bother with all of that, so I recreated the Giba memory configuration that we kind of set up on Officinalis, and just ran some CPT benchmarks there, both looking at the things that we set and then also looking at also saying the tcmalloc thread cache to 60 megabytes instead of 128 megabytes. And the overall memory usage looked very similar to Giba. We ended up right around a gigabyte before the thread cache changes, and a little over, like 925, I think, when we reduced the tcmalloc thread cache, and it was fairly stable through 4K random writes, which is usually a fairly decent test to invoke OSD memory growth. There are situations we can use more for sure. Especially we found Neha around the PG log, or sorry, PG splitting. That's a situation that could potentially invoke significant OSD memory growth. But this got us really close to what we were seeing on Giba, which is great. There's a little more to it that I was able to investigate. On OSD startup, we were using around 280 megabytes of RSS, but most of that was in the page free list for tcmalloc, like 260 megabytes of that. In reality, we were using, according to tcmalloc, only about 20 to 30 megabytes of memory for the application. The RSS memory usage after we told tcmalloc to release memory was around 50. So figure at startup, that's kind of where we're sitting, is in that ballpark of like, maybe 30 to 50 megabytes of RSS memory usage, somewhere around that. Once we invoked an RBD prefill workload, which is essentially 4 megabyte writes, immediately OSD memory usage shot up to around 450 megabytes and then progressively grew from there as we started filling in stuff, up to peaking somewhere around 480 to 500 megabytes of memory usage, RSS memory usage specifically. After the prefill finished, then this test started a 4KB random write workload, and memory again shot up to about 900 megabytes to a gigabyte, depending on the tcmalloc thread cache setting. So we saw this significant growth as soon as we started doing small I/O. And this is all very, very in line with what we've seen in the past, especially in relation to the O-node cache in BlueStore. We see that the O-node cache especially seems to cause a lot of memory fragmentation, but it's not the sole thing. There's definitely other stuff in here where we see memory growth well beyond what we see based on the mempool counters and based on some other things. It's pretty interesting. So I went back and tried to look at using the tcmalloc heap profiler after we had kind of done some of these different workloads. And the results are in the Etherpad there. Since we don't have a lot of time, I'm not going to open up and just walk through them, but feel free to take a look if you're interested. There's some really interesting stuff there. I will say that the in-use numbers I don't trust. tcmalloc is claiming, or pprof, one of the two, is claiming that we're using way more memory or have way more in-use memory than we do. So I suspect that maybe it's missing some, possibly. I trust the alloc data a lot more. That looks a lot closer to what I would expect to see, and it's very high. We do a lot of memory allocation, insane amount of memory allocation, but that's very similar to what I've seen in instrumenting the OSD in other ways previously. And it's really interesting. I mean, buffer list is clearly the big thing here, right? We allocate tons and tons and tons of memory in buffers. So that's really big. But there are some other interesting things there too. Finally, Radek and I sat down a while ago, back in 2020, I think, and tried to create a per thread ring buffer, specifically for the use case where we're appending memory, like little appends for encoding. And I went back and started testing that with master again. And it turns out that if we limit the size of memory allocations for the ring buffer to be within like 64K or within 8K, we can actually get a little bit of a memory usage gain by doing that. Even though we're allocating more memory per thread for that ring, it lowers fragmentation enough that we see a small win out of it, it looks like. On the order of 8 to 16 megabytes maybe. I pretty consistently saw in the configurations I was looking at that memory usage was down a little bit despite allocating more memory for this thing. So that was really interesting to see. But appends aren't the big consumer. We improved that a couple of years ago by changing the way that works so that we don't just do lots of tiny little appends for the append hole use case. We grow it if there's lots of little ones, kind of the way the vector works in C++. So that does not appear to be the real win. Maybe the real win, I suspect, would be to change the way that the messenger works to allocate a block of memory and then not allocate memory for buffers and then move them, but rather to just have pre-allocated memory and then use them and send a pointer around or whatever. That's a lot of work. I don't know if it's worth it, but if you look at those pprof profiles, the messenger allocations seem to be a fairly big percentage of the overall allocation behavior, along with other things. You'll see it in there. So that's what I'm looking at here. I don't know what the right route is to reduce our memory usage further. Right now, we're hitting kind of a hard wall at 900 megabytes RSS in the Ceph. We could probably make it a little smaller, but fragmentation is a pretty big problem to lower it further, I think. And that's what I got. Any questions or thoughts on any of that? I know we lost a couple of people here.
Yeah, I think in general, I would really like to see with all the tunings applied and stuff when we run workloads, what kind of behavior do we see or where the bottlenecks lie, and how further do we need to go kind of stuff.
I suspect that what we've done is we've lowered the steady state memory usage, right? Like we've done all these things that are really clear consumers of memory, and now our steady state looks lower. We got it down to like a gig, right? But if there are things that consume memory that we're not controlling here, we could still see big spikes, maybe proportionally bigger spikes than we see with more memory.
Yep, especially recovery, scrubbing. These are all potential candidates. Yep.
Exactly. And yeah, fragmentation is awful. I mean, TC-malloc does about as good of a job as we've ever seen in terms of controlling and dealing with Ceph's behavior, memory allocation behavior, our penchant for allocating little things all over the place. And even TC-malloc struggles with what we do. Certainly libc-malloc deals with it far, far less gracefully than TC-malloc does. So if we want to make this better, if we really want to make it better, it probably means changing the way that we allocate memory. That's my opinion anyway. Gabby, I'm gonna call you out just briefly here. I know you were kind of interested in some of this kind of stuff. Does this sound like what you've been thinking? Because we've talked a couple
Yeah,
times.
I just sent you an email for something I've been thinking about. Here they try to find projects for third and fourth year students to tinker with Ceph. They have to do some kind of practical work as part of the degree, and they ask us to suggest projects. So I suggested something around those lines. So I'd really appreciate your thoughts on this thing. I know it's very vague and very general, but after speaking with Mark from RGW, he convinced me that maybe it would be easier for students to start with RBD, but the idea is still the same. So basically what I was suggesting is end goal, which is done there with multiple steps, just to allow students to always have something working, and even if the project proved to be too big, they can still have something to show on the resume. But end goal would be that the client would send the OSD how much data is planning to send, on talking about big jobs. And then they will break it into multiple short steps. OSD would still do single allocation, update RocksDB once, and then send the data to be written to GlueStore, but bypassing RocksDB and bypassing all the allocation. So I know it's very tricky to do. It's really easy to say this, but I know that the detail is going to be hell. So that's why I suggested different approach. It could be done by them, but it's of course going to be less useful for us. So if you could review it.
Yeah, I'll take a look, Gabby. Even if it doesn't fix any problems, just having somebody going through and looking at where we're allocating memory and where we're freeing memory, just having a really clear view of what kind of behavior we're requiring of TCmalloc and updating that to make sure we understand what that really looks like would be super, super useful.
Yeah, so I'm still not sure that this thing would be possible to do, or if it's possible to make really into something functioning, but it might just be able to prove where the money is. So hopefully they will be able to do part of this. I really try to break it down into mini steps that even after the first step, they'll have something they could present, because it might be that even the first step would prove to be too difficult to do. And I also want your opinion on something else. Once this meeting is over, there's some discussions we're having with the IBM folks, and I'm still trying to understand the cost of doing crash calculation on the client side. And how does it scale when the map is big? The numbers I was shown by the IBM folks, which might be completely wrong, seems to indicate that when the map becomes big, we are able to do very few calculations, even on a strong CPU, which seems crazy.
Sorry, that we do very few calculations, did you say?
Yeah, so they created a machine with, I think, a configuration of 16 servers, 16 client machine, and 1,000 OSDs. And when running on Intel x86, they were able to get about 25,000 crash calculation per second, which is crazy. It means the client won't be able to do more than 25,000 IOPS.
I've seen clients faster than that. Surprising.
Yeah, sure. I mean, I've seen them doing 500,000 and more. So I don't know if it's because they are using multiple cores or if it's because they did something very silly. So at first they tried to do crash on a very small map. The map, I think their map was just using minimal configuration with 3 OSDs, one client, 3 OSDs, and then they were able to do millions of crash calculation. When the map becomes 16 client and 1,000 OSDs, they drop from maybe a million calculation into 25,000.
Okay.
So I don't know. Again, it might be that they only use a single core, but still, the scaling issue here is frightening. I'm still hoping that they did something very wrong.
It's not surprising to me that you would see it be slower with a larger map, but that is dramatic.
It was 40x.
Yeah.
I mean, I would expect maybe twice, 3 times as slow, but does it mean that crash calculation are polynomials? Every time you do a crash request, you have to do a full scan of the whole thing. Doesn't make sense to me.
I think we need to know more information.
I can put you on the mailing list there. But it's really something looks unreasonable. I don't expect. I mean, I understand that if the map is very big, once there is failover, failures, disconnect, failover, fallback, the calculation is going to be polynomial. But
Greg, you probably know crush better than anyone else here. Do you have any thoughts on that?
But you calculate it only on changes. You don't calculate it on every IO.
Yeah, I understand. So I'm saying that thing, the recalculation of the rebuild of the map, I understand it must be polynomial. That makes sense. But they are trying just to do calculation. Where should this IO go? And that
but that's where the IO goes doesn't have any calculation. It's you get the object name, you create hash out of it, and you go to the PG. The PG is in memory. You don't do any calculation on the IO path.
In theory, you are correct, but I think there are a few extra steps because you have to check for snaps and for a few others. But I don't think it should be.
But it's not calculate. It's not crash calculate. Yes, but it shouldn't be crash calculation. Again, the crash map is in memory. You don't do anything with the crash. You may need to check all kinds of stuff to see what the object name is, but
let me see.
I lost track of most of the conversation, but yes, we do calculate the crush mapping on every IO. There's no cache of crush of hash IDs to crush buckets or OSDs. So it runs that whole calculation every time.
The PGs on every IO, you calculate the PGs. Which PGs?
No, you calculate for an IO. You need to target it to a PG, and that requires running a hash and then mapping it to the PG, and then the PG needs to be mapped to an OSD, and that is a calculation. It's looked up if the OSD map has a PG temp or one of the various other overrides we have, but otherwise it's a calculation, and we don't cache it. And it is not, and the whole point of crush and the OSD map is to not encode the lookup in the map. It's a calculation.
Greg, do you remember
times about caching them, and I don't know why it never happened. I think it just was never quite important enough because for most people you don't notice it.
Greg, do you remember what the time complexity is, or do we?
Greg, let me just put something into perspective. And actually, this thing might be a good way to approach it. IBM is trying to put a Ceph client, Ceph RBD client, on a SmartNIC, and the SmartNIC has a very a very powerless, not power,
Limited.
very limited
Yeah.
power to
You
calculation.
don't need to
Smart
convince me
lead,
that
when he's
maybe we
doing
should do
calculation,
caching
is using
of those mappings,
is using
but we
ARM.
don't.
So one thing we tried to suggest was the solution that we are trying to push, or sorry, that is currently under development, assumes that every OSD going to have a gateway solution where when the IO arrives to it, it's going to do a full verification, and if it belongs to it, it's going to push it down. Otherwise, it's going to be forwarded. So if we could cache the calculation, and even if we miss some calculation, even if
Yeah, that's
I
fine.
don't know,
It
one
just
out
it
of
doesn't
100
exist now.
going to go
That's
to the
all.
wrong OSD, that's no big deal. It's going to be forwarded again. But we
Yeah,
don't
and
want
that's
to take the full
fine.
calculation.
But it is not how it works right now. To answer your question, Mark, 10 or 12 years ago, it was on the order of 10 microseconds with the maps that we tested it on. I don't know how dependent that is on the map complexity and if they've gotten more complicated or not. I don't know how much it scales with CPU frequency.
Yeah, I wasn't sure.
It was trivial when we were worried about it on hard drives, and I don't think it's been re-examined since then, except
Yeah,
occasionally when someone goes, we're spending some time in Crush. Yeah, you could try implementing caching, and then they don't.
yeah. I couldn't remember if in in Sage's thesis, if he actually talked about the time complexity or not. But that was
but it was running, but it was, when you cared about running it on hard drives, and you could say, hey, it doesn't take any time that matters.
yeah. No, yeah.
Many things were less examined at that
But Greg, you
now.
need to calculate the entire map or just the map for the specific PG, which is much simpler because it doesn't depend on the number of PGs. You just calculate for the specific PGs which OSDs to use.
Yes, that's right. You calculate for the you run a very basic hash from object ID to PG, and then you need to run the crush mapping for that PG ID to the OSDs it's on. And that calculation, 10 or 12 years ago on CPUs then and crush maps from then took about 10 microseconds.
How big configuration are you talking about?
I have no idea.
Yeah.
Because we also tested this on a very small configuration. It was screaming fast. On a tiny configuration, it completed it in 1 microsecond.
I mean, CPUs are faster than they were 10 years ago, so maybe that's how long it takes now. But also, yes,
but
a tiny configuration.
But once the configuration grew to 1,000 OSDs and 60 nodes, then it become, what was this, 40 millisecond? That's...
Sure. Yeah.
I mean, okay, that's crazy. Yeah,
that's time.
Yeah, no, that is too much time.
Sorry, 25 millisecond.
I mean, the last time I saw it get really long, I think it was as a result of I don't remember what was triggering it, but we were getting retries on lots of.
Sorry. Again, I'm sorry. I'm just confusing everybody. 40 microsecond. We grew from 1 microsecond into like 25 or something microsecond.
It's probably worth actually looking at how the algorithm works, right? Like rather than just kind of guessing at it. Like it's probably worth just having someone take a look.
I can tell you that the last time it got really long, or that we saw it get really long and did something about it was as a consequence of out OSDs still being in it. So you hit lots of retries and backoffs, and those can conflict pretty badly. And I think that might have been partly resolved in one of the straw iterations. I don't remember.
I think wasn't that like maybe straw 2 the why it got developed? I don't remember.
It was. I think it was fixed in one of the straw configurations. At least one of them was actually about weighting being wrong. I don't know if another one. I don't remember.
Yeah.
I mean, the straightforward answer to this is yes. It's probably worth. I mean, the problem is it depends on the number of PGs that like the client is accessing. It's definitely worth like looking at caching the crush calculations again, but no one has done that yet because it has never quite been worth it. But yes, that is the straightforward solution to attempt.
Okay, but now on your side, Mark, are you guys testing this on the client side? I mean, even if it's going to be 25, 40 microsecond, it's still a lot of money. when you're talking about NVMe SSD?
Client-side RBD and CephFS have probably been the fastest in terms of single client performance. And on the RBD side, which is probably what we've got the most experience with looking at long-term testing, we were far more limited by the implementation of the client-side RBD cache than we were by Crush. Crush very much was not the majority consumer of time compared to other things. But having said that, these are on configurations that are like between, maybe 8 and up to 100 OSDs. We've never done that kind of testing on like 1,000 OSDs that I know of.
So if you think about Bloomberg on CERN configuration, the mega configuration, do we know how much they are being held back by this?
We do not know how much a 1,000 OSD cluster, how much a single client trying to get good performance on a 1,000 OSD cluster, how much Crush is contributing to that. We do not know that.
Maybe we should try and get the numbers because it might trigger some changes to this. Maybe this gateway design that we are trying to push on the IBM cloud side, maybe that thing could be actually a general purpose thing, or maybe it could be used if you have more than some OSDs. Maybe you say, you know what, we could do flat calculation if you have no more than, 256 OSDs. Once you go past this, you know what, we're going to give you an approximation and the OSD is going to do a secondary verification.
Well, it's been a few years since I looked at Crash, but I recall that when you draw a straws, it just has to take a pick from any representation on a certain level. So it will definitely be a very different complexity if you had like a binary tree of hierarchy versus having everything just on same level. Because if you have 1,000 OSDs on one level, then it will pick from all of them, and there will be 1,000 challengers for a specific seed to get being chosen for a PG set. If you have that tree, it will just reduce that set. I'm thinking it might be something like that, that if you have a very long time of calculating Crash, just maybe.
That would not surprise me, Adam. That seems very like a very good observation. Having said that, I don't actually know how much it actually does matter. Like Greg said, I mean, Gabby, it sounds like you guys are seeing evidence that maybe it does, but it's certainly not been something.
About this evidence, it was done by somebody from IBM, and we just said something, try it, and so I don't know. I cannot say for certain that the numbers are correct. I didn't do any of the calculation. I don't even understand the calculation. That's why I was trying to think about it.
I will say that, especially like on something like a SmartNIC, right? If you're going for really high IOPS, single client, big cluster.
And such. I mean, let's talk about our side. Forget about IBM. They're not interesting.
Sure.
We have big customers with some very big configuration. Do we know what's the impact of scaling? And I know in the past, Sam was suggesting some kind of limited map. So don't allow everybody to see everything. You could just create some kind of sub-configuration. And is this something that we use day to day on the customer?
We don't have any mechanism right now for like reducing an object in a pool to be restricted to only like a subset of the OSDs that are there, that I know of anyway. Like we can't just have like, an RBD pool where a given block is represented by, a small subset of the OSDs.
Yeah, that proposal was specifically for this NVMe gateway, or similar sorts of things where the microseconds really do matter.
Yeah, but so I that is when I heard this proposal, but I was just wondering if this is something
Yeah,
that we
no, it does not
use in
exist.
big configuration, because in theory they might suffer from the same thing. You could say maybe shrinking. If the map is very big, do you really need to see the whole map? And again, I'm assuming that it is a real problem, and really, when map is big, crash calculation that doesn't scale very well. I don't know that maybe if you do the testing and somebody would truly understand it, we're going to find that it's a linear scaling, and we just didn't do the right calculation.
I mean, the thing is that it should depend. The variables should depend on the number of buckets you have to descend through and how many times you have to back off and retry. I don't think the number of OSDs as an absolute number matters. I guess, given that they tend to be divided into racks and rows and stuff, probably there's like a logarithmic scaling as you split those up. But in general, it's just about the number of times you have to go through a bucket, a crush bucket, and run a hash.
I mean, the
I
hash
could
is
be
a
missing
very
something,
simple.
but
Yeah.
yeah.
Who would know and be able to go on the calculation and see if we use the correct method to do the calculation? We ran some kind of a script. Let me find the script.
I mean, nobody's going to know offhand. Someone will need to go look at the crush code again and look at the script you ran and identify if it matches. If you didn't just run crush, I would just like make up a couple of maps of varying complexity and run crush on them in the environment you care about. You can, there are lots of ways to invoke that using the crush tool and the testing, and it has testing built in.
So that was the suggest what they use. Just 1 second.
Uh-huh.
Yeah, sorry, my daughter just entered.
Yeah, so that is how I would test it. At least, basically. I don't know what the options actually do, but that looks right to me.
First, they use a very minimal settings. I think just 3 OSDs and 1 client, and they could do 1 million calculation. And then we told them, no, that's not the configuration. Configuration is 16 clients and 1,000 OSDs, and then
well, I mean, the number of clients doesn't have anything to do with crush, right? What?
I don't know. I didn't know if there's any dependency, but okay, so it's good to know. So they only depend on the number of OSDs. So for 1,000 OSDs, they range from 1 microsecond per calculation into 40 microseconds.
Yeah, I don't know. We'd have to look at the maps, and someone would have to look at the code and figure out why that happened, because that surprises me. But it's possible that we just never noticed that.
All fits inside L1 cache and so on. And when the map grows, then it doesn't fit L1 cache, and you start to pay DRAM. I don't know if it's L2, L3, or even DRAM.
Yeah, I'm not sure either.
Certainly, running that through perf would be useful to look at things like cache misses and everything else around it. And you can try running my wall clock profiler here as well, because this should be fairly easy to do. And just see where it's spending time.
Should we add you guys to the mailing list there, or you guys won't be interested? I mean, Mark, you probably have no way to escape it.
Yeah, I mean, add me. That's fine. I'm pretty busy right now, but I could try. But yeah, I mean, just.
Even if you just be there, you might be able to capture some of the silliness that we're seeing. And Greg, I don't know, should I
I mean, I can repeat the things I've said here in various ways if it becomes necessary. I'm not going to be able to donate any work to it, but I don't
Okay.
mind providing a
So
historical perspective.
okay, so I'm just adding Mark because his title requires that you'll be included in everything which is performance.
Gabby, is it possible that they could have a live session so that we can actually do like real work here on this and not just talk about it?
Yeah, sure.
Okay, let's do that, and then let's just profile this thing and see where we're spending time. And that will give a good indication where to code and where in the code to start thinking in.
Okay, but
And then I'm going to stick you on it.
Let me back down a bit. Sure, it's possible, but I don't know. I need to talk to them and ask them to give us access to the machines and such. It's not my machine.
Well, they can do it too. Like the thing they should have perf. They should have RPMs for perf, so they can run that directly. And then my thing should be really easy to compile as long as they've got like GCC and elf utils on the system, which they probably do. So
Adding work to the thread. So Mark, you're on the thread. I'm going to forward you the full thing. This silliness.
is this like a Google chat thread? Is that what this is?
No, it's a very long email.
Okay.
And I'm forwarding you the email. I don't like. So first you have the full discussion, but I also added you to the thread, so everything new you'd be included.
Okay. But yeah, if we profile this thing, it'll probably tell us where we're spending time, and then we can figure out. I mean, you can or somebody can take a look at it and figure out, okay, does this make sense that we're in this area of the code constantly, given what it's doing?
So what they also tried to do was comparing performance on ARM CPU versus Intel. And the surprising thing was that ARM was not so powerless as I was expecting. I was expecting in order of magnitude. I think it was like factor of 3. Intel was like 3 times faster than ARM, which to me sounds very surprising.
Well, I mean, I guess it depends on what we're hitting as the bottleneck, right? I mean, ARM in some cases is pretty good. It's bad at I/O, but maybe if everything fits in cache nicely, ARM is doing okay.
So I don't know exactly. Actually, I don't know at all. How would the map look for 1,000 OSDs? How big would it be? If you can fit it inside an L1 cache, because this thing is just testing script doing one request after another, so eventually everything will be in cache if it's not too big. So L1 cache I think is 64K, and L2 is like 512s, but it shares between all the cores. But in this case, they are probably all the cores are probably using the same map, so it's no problem.
I suppose that's the other thing is whether or not this benchmark that is being run actually is representative of what a real client would do in terms of the cache, right? The L1 cache.
So in our scenario, it's probably not extremely wrong, because we are considering splitting the work into 2 paths. Because on the SmartNIC there is this FPGA path which could move the I/O very fast. They can move the data and the request wire speed. But it's pretty useless for us because every I/O need to do crash calculation. And you cannot do it on an FPGA. So what we do, we run everything on our processor. Our processors are very bad in doing that. So I suggested a middle way in which we will queue the request on the NVMe side, on the NVMe queue before they come to the FPGA, the FPGA would look at them, push just the I/O parameters to using some kind of ring buffer to the ARM cores. The ARM cores would do crash calculation and push it back. Once you have it, it can process the I/O from the queue. Now, if we assume that the I/O are going in steady rate and queuing is good, then you should be able to do close to the number of what crash calculation we can do. And the ARM processor would be doing 90% of the time just crash calculation, plus some maintenance jobs like, I don't know, if the crash map have to be updated, they have to do something. But on the normal flow, that's all they be doing, just crash calculations. So the cache is actually going to be, it's going to be reasonable to assume that the cache is going to be all around crash calculation. But how big is a crash map? And can we maybe make it smaller because by fitting this into L1 cache or L2 cache, maybe even L3 cache, that might be huge difference in performance.
Yeah, absolutely. That's why I think we got to actually start measuring what's going on when they run this.
Okay, so I'm going to say that we need your help in profiling this problem.
Sounds good.
Apply to all. Chris, I added performance by, actually I just added Mark to this chat. He can help profile crash calculation. Example given, is it L1, L2 dependent? And send. That was this.
The other thing I was thinking is that the perf team at Red Hat had some changes to look at exactly these kinds of issues, to perf to look at exactly these kinds of issues. And it might be worth reaching out to one of them to also provide guidance on some of this.
Who are they?
I don't remember who it was that presented. Someone presented some of their work a couple of years ago, though, to the Ceph community. See if I can find. I'll try to look it up and see if I can find out who it was. One of the guys over there, though, is kind of an expert in this area, so it might be worth dragging him in if we can't find it ourselves. All right. Well, we're way over time. Let's wrap this one up and move on.
Please take a look at the other email I sent you about projects, and keep in mind it's a couple of students. One of them is third year, one of them is fourth. I think the fourth year is working now as intern in Mellanox. The third year, I don't know where he's working, and both of them are interested in doing real system level work.
Okay, cool. Sounds good.
Yeah. Just
all right.
And you could just assume that at first I wrote that everything should be done around RGW because RGW is using big IOs by default. 4 megabyte is a very common size for RGW client, but so I said that's going to be a real use case. But I was convinced by the other Mark that RW is too complicated for them and they should start with RBD. If everything proved correct, we could then say the same thing should apply to RW. So don't ask them to understand RW code. But aside from the RW, the rest is okay. And actually, one more thing, there's something I'm talking about the network that you don't have to wait on. If there's replica, you don't have to wait on ask from replica. And then I realized you don't. It's okay. That thing is very easy to do. But
yeah, like I said earlier, the big win for me would be if someone can really take a look and figure out how our memory allocations look just in the code. That'd be huge if they can verify where we're allocating, where we're freeing, and how much we're doing in different areas. Some of that pprof output that I provided in the Etherpad as kind of a start in that direction, but having someone really run with it would be great.
Okay, so this thing was only around the messenger.
Yeah, that would be fine too.
Yeah. Request buffers.
Cool.
Okay, that's all.
All right, sounds good. Have a great week, everyone. The 4 people we got left. Bye.
Yeah.